Alright, so in this problem, I have 2 to the power of x is equal to 3 to the power of x. So, the first thing I'm going to do is I'm going to take the log base 2 on both sides. So I have log base 2 of 2 to the power of x is equal to log base 2 of 3 to the power of x. Now, if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this is going to equal b times log a. So now I can move x here to the front, and I can also move x over here to the front. So now I'm going to have x times log base 2 of 2 is equal to x times log base 2 of 3. Now, log base of 2 and 2, these two are simply going to cancel out, because if the base and this are the same thing, then they simply equal to 1. So now, from my left-hand side, I'm simply left with x is equal to x times log base 2 of 3. Now, I'm going to subtract x times log base 2 of 3 on both sides. So these two cancel out. And now I'm left with x minus x log base 2 of 3 is equal to 0. So now I'm going to factor out x from the left-hand side. So now I have x times 1 minus log base 2 of 3 is equal to 0. Now if I divide both sides by 1 minus log base 2 of 3, these two cancel out, and now I am left with x is equal to, well, 0 divided by 1 minus log base 2 of 3 is simply 0. So I'm left with x is equal to 0. So now, to check, I have my equation 2 to the power of x is equal to 3 to the power of x. And we know that x is 0. So now I have 2 to the power of 0 is equal to 3 to the power of 0. Now remember, anything to the power of 0 is simply equal to 1. So 2 to the power of 0, that's equal to 1. And 3 to the power of 0, that's also equal to 1. So I have 1 is equal to 1, meaning my solution is right. So make sure to hit that thumbs up and like button, and make sure to subscribe. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So I have 2 to the power of x is equal to 20 to the power of 10. So the first thing I'm going to do is I'm going to take the log on both sides. So now I have log 2 to the power of x is equal to log 20 to the power of 10. Now if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, log 2 to the power of x, I can move x to the front, and log 20 to the power of 10, I can move 10 to the front. So now I have x times log 2 is equal to 10 times log 20. Now, if I divide both sides by log 2, these two cancel out, and now I'm left with x is equal to 10 times log 20 over log 2. Now log 20, I'm going to rewrite that as log 10 times 2 over 2. And now if I have something in the form log a times b, simply equal to log a plus log b. So in this case, log 10 times 2, that's going to equal log 10 plus log 2. Now I have this over 2. Now, if I distribute the 10, I get 10 times log 10 plus 10 times log 2 over, sorry, this is actually log 2, not 2. And now, this is the same thing as 10 times log 10 over log 2 plus 10 times log 2 over log 2. Now, log 10, that's actually equal to 1. So now I have x is equal to 10 over log 2 plus 10 times log 2 over log 2. And these two log 2's are actually going to cancel out. So now I'll be left with x is equal to 10 over log 2 plus 10. Now, log 2, this is equal to 0.301. So now I have x is equal to 10 over 0.301 plus 10. And 10 over 0.301, this is equal to 33.2226. Now I have this plus 10. So now this is the same thing as 43.2226. So this is my answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. Now make sure to stick to the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 2 to the power of 24 minus 1. Now, 2 to the power of 24, this is the same thing as 2 to the power of 12 times 2 minus 1. And now if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So in this case, 2 to the power of 12 times 2, that's the same thing as 2 to the power of 12 to the power of 2. Now I have this minus 1. Now, we know that 2 to the power of 10 is equal to 1024. So 2 to the 11, this is equal to double of 1024, which is 2048. And finally, 2 to the power of 12, this is going to equal double of 2048, which is 4096. So now I have 4096 squared minus 1. Now, 4096, this is the same thing as 4100 minus 4. So I have this squared minus 1. And if I have something in the form a minus b squared, this is equal to a plus b times a minus b. So 4100 minus 4 squared minus 1, and 1 is the same thing as 1 squared. So now this is the same thing. Sorry, it's not a plus b times a minus b, it's actually a squared minus 2ab plus b squared. So we have 4100 minus 4 squared. So this is going to equal 4100 squared minus 2 times 4100 times 1, or sorry, times 4 plus 4 squared. Now 4100 squared, that's going to be 1,681,000. Sorry, 16,810,000. Now I have this minus 32,800 plus 16, and then we can't forget our negative 1 at the end. So now all of this is going to equal 16,777,200 plus 15, which is equal to 16,777,215. So this is my answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. And make sure to stick to the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 2 to the power of 100 minus 2 to the power of 99 minus 2 to the power of 98. So first off, 100, this is the same thing as 98 plus 2. 99, this is the same thing as 98 plus 1. And 98, that's the same thing as 98. So now if I replace these in for 199, I get 2 to the power of 98 plus 2 minus 2 to the power of 98 plus 1 minus 2 to the power of 98. So now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, 2 to the power of 98 plus 2, let's first start with that. That's going to equal 2 to the power of 98 times 2 to the power of 2. Now I have this minus 2 to the power of 98 plus 1 is going to equal 2 to the power of 98 times 2 to the power of 1. And 2 to the power of 98, we're simply going to leave that by itself. We're not going to change that. So now from here, you can see that all three of these terms have 2 to the power of 98 in them. So now if I factor out 2 to the power of 98, I get 2 to the power of 98 times, well, 2 to the power of 98 times 2 to the power of 2 divided by 2 to the power of 98, simply 2 to the power of 2. And now negative 2 to the power of 98 times 2 to the power of 1 divided by 2 to the power of 98 is negative 2 to the power of 1. And finally, negative 2 to the power of 98 divided by 2 to the power of 98 is negative 1. Now I'm going to go ahead and simplify this. So now this gives me 2 to the power of 98 times 2 to the power of 2 is 4. And 4 minus 2 to the power of 1 is simply 2. And I have minus 1. Now this is the same thing as 2 to the power of 98 times 4 minus 2 is 2, and 2 minus 1 is 1. So I have 2 to the power of 98 times 1, and this is simply equal to 2 to the power of 98, because anything times 1 is itself. So this is my answer. Alright, so I have x to the power of 4 minus 16 is equal to 0. Now to start, x to the power of 4, this is the same thing as x to the power of 2 times 2, because 4 is 2 times 2. And 16, this is the same thing as 4 to the power of 2. So I have x to the power of 2 times 2 minus 4 to the power of 2 is equal to 0. So now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2, I'm going to write as x to the power of 2 to the power of 2. Now I have this minus 4 to the power of 2 is equal to 0. Now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is equal to x squared and b is equal to 4. So now I have x squared plus 4 times x squared minus 4 is equal to 0. So now x squared minus 4, this is the same thing as x plus 2 times x minus 2. So now this is going to give me three equations. I have x squared plus 4 is equal to 0, x plus 2 is equal to 0, and x minus 2 is equal to 0. So first off, for x squared plus 4 equals 0, I'm going to first start by subtracting 4 on both sides. So now these two cancel out, and now I'm left with x squared is equal to negative 4. Now, to solve this, I'm going to take the square root on both sides. So now I have the square root of x squared is equal to the square root of negative 4. Well, the square root of x squared is simply equal to x. So I have x is equal to the square root of negative 4. That's the same thing as the square root of 4 times the square root of negative 1. And the square root of negative 1, that's equal to I. So now I have x is equal to the square root of 4, I. Now the square root of 4, that's the same thing as positive or negative 2. So I have x equals positive or negative 2i. Now for x plus 2 equals 0, I'm going to subtract 2 on both sides. And now I'm left with x is equal to negative 2. So that's my answer. And for x minus 2 equals 0, I can add 2 on both sides. I'm left with x equals positive 2. So my four solutions are x is equal to 2i, x is equal to negative 2i, x is equal to 2, and x equals negative 2. Alright, so I have 4 to the power of x is equal to 8. So now to solve this problem, first off, 4, this is the same thing as 2 squared. So now I have 2 squared to the power of x is equal to 8. Now 8, this is the same thing as 2 to the power of 3. So now I have 2 squared to the power of x is equal to 2 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x, that's going to equal 2 to the power of 2 times x, which is 2x, which is equal to 2 to the power of 3. Now, if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So in this case, 2x is equal to 3. So now to solve this, I'm going to simply divide both sides by 2. These two cancel out, and I am left with x is equal to 3 over 2. So this is my answer. Now another way of solving this problem is I have 4 to the power of x equals 8. So now, if I have something in the form a to the power of x is equal to b, this means that x is equal to log base a of b. So in this case, x is going to equal log base 4 of 8. And now this is the same thing as log 8 over log 4. Now log 8, well 8, that's the same thing as 2 to the power of 3, and 4, this is the same thing as 2 to the power of 2. So I have log 2 to the power of 3 over log 2 to the power of 2. Now I can simply move the exponent to the front for both of these. So now I have x is equal to 3 times log 2 over 2 times log 2. The log 2 simply cancel out, so I'm again left with x equals to 3 over 2. So that's two methods of solving this problem. And now, to check, I have 4 to the power of x is equal to 8. We know that x equals 3 over 2, so I have 4 to the power of 3 over 2 is equal to 8. Now 4 to the power of 3 over 2, this is the same thing as the square root of 4 to the power of 3. And 4 to the power of 3, that's equal to 64. So I have the square root of 64 equals 8, and the square root of 64 is 8. So I have 8 is equal to 8, and because this is right, my solution is right.